All right, Algebra 2, welcome to your section 4.4 videos. We're going to continue kind of where we left off in 4.3. We're still doing pretty much the same thing. We're going to factor some more in this section. But now, okay, so we've been working with the standard form. And we're still going to work with the standard form. But now what's different is that if you remember in 4.3, our A was strictly 1. Our leading coefficient was always 1. So we really only had to worry about factoring this. Okay, but now we're throwing that out the window for section 4.4. We're going to let A be whatever it wants to be except 0, of course, right? We talked about that in section 4.1 and 4.2. We want to go ahead and be able to factor any quadratic expression, no matter what coefficient is on the x squared. But now that kind of brings a little bit of an issue, because if you remember from 4.3, if I did x plus 2 times x plus, I don't know, 4, I don't know why I did that. Give me a second. I don't know why it set it to be fun. There we go. Okay, back to business. When we multiply this out, we get x squared plus 6x plus 8, right? And we kind of took a look at how 8 is 2 times 4, and 6 is 2 plus 4. Okay, so that's how we came up with that general rule. To factor, you look for the factor pair of 8 that adds up to 6. Okay, look for the factor pair of 8 that adds up to 6. But now what happens when I throw a wrench in the operation and I put a 3 and a, let's say a 5 here? Okay, so what happens when I do that? Well, we have extra work to do, right? 15x squared plus 20x plus 6x plus 8. Now it's way more complicated. Now it's not so clear where every single number comes from if you're just starting with this right here. Like if I asked you to factor this, it's not clear where each of these numbers comes from, because yeah, the 8, it comes from 2 times 4, but there's no factor pair of 8 that adds up to 26 because they're just not big enough, right? So this 15, the 5 and the 3 kind of ruined our lives a little bit. So we got to go ahead and try to make our lives a little better, okay? So what the issue is now is, if we try to just guess and check our way out of it, let's say for this one, we try to guess and check our way out, not only now do we have to worry about factor pairs of 6, we also have to worry about factor pairs of 5, because you saw how the leading coefficients of each of those binomials affected the middle term. Okay, so we know now we have to deal with 1 and 6, 2 and 3, and then 1 and 5. But now if you think about it, we know the 1 and the 5 is going to go on the leading, is going to be the first term in each one, 5x, x. The issue is that I have 4 possibilities here, because 5x plus 2 plus times x plus 3 is going to be a very different product from 5x plus 3 and x plus 2. Same thing with 5x plus 1, x plus 6. That's going to be different from 5x plus 6 and x plus 1. And go ahead and convince yourself that those are different by multiplying that out, and see that each of those are very different quadratics. Because of that, brute force is not our friend anymore. We can't really go ahead and, we could, but it would just be very inefficient. It would take you longer than it needs to be, okay? So let's learn a new method right now that will be not only surefire, like you'll get the right answer every time as long as you do each of the pieces correctly, but it'll take us hopefully longer than just kind of brute forcing away. So let's go ahead and look at the steps of this new method. The first thing you want to do is factor out a GCF, if there is one. So step 1 is optional. Sorry, step 1 is not always going to happen. It's not optional. Step 1 is not always going to take place, because if you look at this one specifically, none of these have a factor in common. There's no number I can divide into 5, 17, and 6 aside from 1. So there is no GCF. So we can go ahead and skip that step. Step 2, we're going to do something very different here from what we're used to with normal factoring, or sorry, with factoring with this being just 1. We're going to multiply A and C together. Okay, so our A is 5, our C is 6. 5 times 6 is 30. All right, because then this will help. The reason why we do this is because it'll help us keep track of all the factors of 5 and all the factors of 6 in order to get the correct configuration the first time around. Step 3, what we're going to do is find the factor pair of A times C, that sums to B. Okay, so that part is familiar. So AC is our new C. Instead of just looking at C, we're gonna do A times C and look at factors of that. So 30, let's look at the factors of 30. We have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Looking at our quadratic expression, we know they're gonna have to be the same sign, and because of the positive C, and because B is negative, we're going to have them both be negative because they're going to have to add up to a negative number. And they're the same sign, so the only way to do that is by making them both negative. So which one of these is going to give us negative 17 when we add them together? Our winning ticket is -2 plus -15. That's the only one that's going to give us negative 17. All right, step 4. Here's kind of this step you might not be familiar with. It's kind of it's very new from what we were used to. We're going to separate bx into the factor pair we chose. All right, what do I mean by that? I mean, we're going to take our quadratic expression, 5x squared, minus 17x plus 6, and we're going to take our negative 17x, our middle term, our bx term, and kind of split that apart into negative 2x and negative 15x. But we can't change any of these operations at all. So we can't change our first term or last term. So we carry those two down, 5x squared plus 6. And now we have in between minus 2x minus 15x, because those are the signs on the two factors. Okay, these signs are these signs. And now let's ask ourselves, did I do something wrong? Is that an okay thing for me to do? The answer is yes. And the reason why is because if you do negative 2x minus 15x, you get negative 17x. So all we did is manipulate our quadratic expression. We didn't change the value at all. All right, and now our final step is to factor by grouping. Okay, and what that means is we group the first two terms and the last two terms. All right, so looking at my first group, what is the GCF here? So we're grouping them up and we're looking for a GCF to factor out from each group. What can I factor out of here? From the coefficients, nothing. There's nothing in common between 5 and 2. But in the x's, they both have at least one x. So I can factor out one x from each. And remember, when you factor stuff out, you're dividing that thing out. 5x squared divided by x, that's 5x. Negative 2x divided by x, that's minus 2. Okay, now always here, no matter what, put a plus. Okay, what we're gonna do next is factor out, and the reason, sorry, I should explain to you why instead of just telling you what to do. The reason why we're putting a plus here is because I want you to understand that these are separate terms that are being added together. I see a lot of students often just not putting the plus, and then they confuse this with a multiplication problem, but that is not the case. We don't get that until the very end. Okay, so always put a plus here to avoid the temptation of thinking you're already done once you get here, okay? So I see a negative here. I'm gonna want to immediately factor out a negative as well. So negative, whatever I'm factoring out from 15x and 6. GCF between those two numbers, yes, is 3. So I'm factoring out a negative 3 here. And what do I have left? Negative 15x divided by negative 3, that's 5x. 6 divided by negative 3, that's negative 2. Now we have two terms. Here is one term, and here is one term. Now you're not confusing this with a multiplication problem because I'm not multiplying everything. I'm just doing these two terms and these two terms. Okay, what do you see that has in common? 5x minus 2, 5x minus 2. So now we factor out one more GCF. 5x minus 2. What am I left with in the first term once I factor out that 5x minus 2? X. What am I left with in the second term? Negative 3. There is our two factors. Okay. Let's go ahead and do one more example together, just so you can try that out again. Okay. So 6t squared plus 7t minus 5. All right, let's go ahead and apply those steps. Our first step was to check for a GCF. There is no GCF, so we can skip that step. Second step is to multiply our a and c. Our a and c is 6 and negative 5. 6 times negative 5, that's negative 30. Next step is to find the factor pairs of negative 30 that add up to our middle term, which is 7t. Okay, so again, here are our factor pairs. Oops, sorry. We know one of them has to be negative. That's the only way to multiply to get a negative number. And we know the biggest number, the bigger number, is going to be positive. Okay, so we know that the bigger numbers, so all of these, are going to stay positive. And our smaller ones are negative. That's the only way that I can add these so that I get a positive number. So which one of these configurations is going to give me a positive 7? Well, 30 minus 1, that's 29. Nope. 15 minus 2, that's 13. Nope. 10 minus 3 is 7. So here's our winning ticket. So we're separating the 7t into negative 3t plus 10t. So 6t squared minus 3t plus 10t minus 5. So now let's do our factor by grouping. Group the first two terms and the second two terms. GCF from the first two is 3t, right? Because I can divide each of these by 3t. What do I have left? 6 divided by 3 is 2. T squared divided by t is t. 3t divided by itself is minus 1, negative, right? Plus, put that plus down. GCF between 10t and minus 5, that's going to be positive 5. I don't have a negative here, so I don't have to worry about factoring a negative out. 10 divided by 5 is 2t. 5 divided by 5 is minus 1. So now here are our two terms, our two pieces. What do they have in common? 2t minus 1. We can factor that out, and I'm left with 3t plus 5. Okay, hopefully that sounds good to you. Rewatch this if you kind of missed any of those steps or are confused by any of those steps, and then go ahead and meet me in part 2.